my blood is flowing faster in here. Okay? Right? So my blood is flowing faster. So then next, what's going to happen and defer to my glomerular filtration rate if my blood is flowing faster here?
Increase.
Good. My glomerular filtration rate is going to increase. And we don't want this, right? We don't want our glomerular filtration rate going up. So we're going to fix that problem by constricting the afferent arteriole coming in. What does it mean to constrict?
To lessen.
They get smaller, right? So when my afferent arteriole gets smaller, what happens to the amount of blood that can come in? It's going to go down, right? I can't bring in as much blood, so my blood flow is going to go down. Now if I have less blood flowing in, what's going to happen to my rate of filtration?
It's gonna
Back to normal.
keep balance.
It's going to go down or lower back to its balanced or normal level. Right? So that's a good way in which we can maintain a nice steady glomerular filtration rate, even though we got up and our blood pressure and heart rate changed a little bit.
So the goal is for it to stay at a consistent, constant rate.
Exactly.
Unless you're in fight or flight, then it
Right.
lessens.
In our normal everyday activities, like just kind of walking, sitting, sleeping, we want our goal is to stay at a consistent rate. If you're in the extreme scenarios, like these dangerous scenarios like fight or flight or congestive heart failure, then that's when we say, no, we don't want any blood to our kidney.
Okay.
Yeah,
So
but here we want to stay consistent.
So there's no scenario where it increases to increase the rate of filtration?
Oh, is there any scenario in which we want to increase the rate of filtration?
So let's say if you poison or have a lot of toxins in your blood and you want to filter.
Right, so there might be a scenario like if you have a lot of toxins in your blood or you have a lot of waste in your blood. In that case, you might want to increase slightly, right, the filtration rate so you can work on getting rid of those toxins. But in your standard kind of everyday scenario, you want to keep it steady. Okay, so did we decide, is this negative or positive feedback?
Negative.
Why negative? Yeah, you see the opposite changes, right? At first our problem was our GFR started going too high, so then we fixed the problem by lowering it back down, and again the key was we got back to normal, back to homeostasis. Okay, great. So that's our first step, right? We want to filter out our blood, get the solutes into our filtrate, and we want to make sure we do it at a good, steady rate. Next step is tubular reabsorption. Remember, this is now our opportunity to reclaim any of the solutes, any of those nutrients and water from the filtrate back into our renal tubules. Or sorry, from our renal tubules back into our blood. So in other words, we want to take all the nutrients we identified, right? The water, the glucose, the amino acids, the sodium, the chloride, and we want to reabsorb them back into our blood so we can keep it. So when we say back into the blood, our options are, remember if we're at the the proximal convoluted tubules in the front, in the beginning, we interact with the paratubular capillary. So we want to take them from the proximal convoluted tubule into the paratubular capillary. The same thing if we move out to the distal convoluted tubules. We want to reabsorb them back in the paratubular capillaries. If we're at the loop of Henle, remember that blood vessel nearby is called the vasa recta. So again, if we're at the PCT, our goal is to get it back into the paratubular capillary. If we're at the loop of Henle, our goal is to get it back into the vasa recta. If we're at the DCT, right, or the collecting duct, we want to get it again back into the paratubular capillary. So the idea is to bring it all back into the blood so we can keep it. Okay. So let's figure out what we can get back.
Sorry, I've heard the paratubular capillaries and vasa recta use it interchangeably, but they're actually distinct places.
So it's the same, the paratubular capillaries and the vasa recta, they're not interchanging, they're the same exact blood vessel, they're just called different names depending on what part of the nephron it's next to. So In general, the holding is called the peritubular capillary, but if it's specifically next to the loop of Henle, they call it the vasa recta. All right, so again, here's our opportunity to reabsorb our nutrients. So that sodium and chloride, we want to keep those, right? Where do we use sodium? Where do we use sodium?
Or action potential?
Yeah, action potentials, right? Depolarization, we definitely need that. Chlorine, we didn't talk about it much, but it's also very important in neurons too. Water, right? We want to retain water, hydrate us. Other nutrients such as glucose, of course we want to keep our glucose for energy. Right? Those amino acids, we're going to need those to build up some protein. And I didn't put in there, but sometimes vitamins, smaller vitamins get put into your tubules. So we want to reabsorb any vitamins to keep in our body. All right, so now what I want you guys to do is take a look at your diagram. We're going to add to it. You want to add in step 2. Remember, step 1 was glomerular filtration. So now add in, right in step 2 in your diagram, tubular reabsorption. And we're going to start off at the PCT. Use an arrow to draw the direction in which your solutes are moving. And then write down which solutes are being reabsorbed. You've already written down a lot of solutes there. So again, use those solutes you have in your PCT and draw the arrow in which solutes you want to be reabsorbed and where are they going. Right, so just take about a minute or two with your partners and make sure you draw in that step 2.